In this video, we are going to discuss about the circle. Before entering into the exercise 10.1, we are going to discuss about the tangent, secant and normal. For example, we take the circle. The line touches any one point on the circle. The line is called as a tangent. If you draw the tangent, it will be intersect and go to the one point. So, the line intersect at any one point on the circle. That line is called as a tangent. So, that is a tangent. Same time, a line passes through the one point of the circle. If any line passes through the one point of the circle, that is called normal. For example, if a line passes through in particular point, then that line is called as a normal. If any line passes through any 2 point of the circle, that is called as a secant. Then you know very well about the diameter. The line passes through the center of the circle, that is called diameter. Then half of the diameter you can say as a radius. We know about the line touch the two surface point on the circle, that is called a chord. So like that we know difference between the secant, tangent, normal, chord, diameter, radius. Okay, so any line touch in particular any one point on the circle, the line is called as a tangent. A line passes through in 2 point of the circle, that is called a secant. Passes through the 1 point, that is called as a normal. Then the line passes through the center and touch two surface of the circle, that is called a diameter. So center to surface any one, that is called radius. So now we are going to enter into exercise 10.1. In 10.1, they ask first question, how many tangent can a circle have? So we can draw the infinitely many tangent to the circle. We can draw the infinitely many. So we can write the answer here. Infinitely many circle. Then they ask a tangent to the circle intersect in dash point. So it intersect only the 1 point. So a line intersecting the circle, the 2 point, that is called secant. That is called a secant. Now only explain the line intersecting the two point of the circle, that is called a secant. A circle can have a dash parallel tangent at most. So we can draw if you draw any one line, for example, I draw the tangent here. For this tangent, we can have one more tangent only able to draw, that will be parallel to the first one. So the both only parallel. So we can draw only the two tangents should be parallel. If we can draw this side also, no problem. But for that tangent, we can draw one more tangent only parallel. So it has only two tangent only as a parallel. So a circle can have a dash parallel tangent to at most 2. Then the common point of the tangent is called a point of intersection. What is that point? For example, this is a circle. If I draw the tangent like that, so that point is called as a point of contact. So it is a common for circle and it's a common for the tangent also. It will be represent the circle and tangent. That's why that point is called as a point of contact. If you draw here, then that point is called as a point of contact. So fourth one, the common point of the tangent to the circle is called a point of contact. So point of contact. Next they asked to find the given BQ at the point B of the circle of radius 5 cm. Meet the line through the center O at point Q, so that OQ equal to 12 cm, length equal to BQ. The length, they asked to find the length of BQ is, what is a BQ they asked to find. You can draw the diagram for this. So they given, so you take the circle. They mention that the point B of a circle from the radius 5 cm meet the line through the center O, a point Q, so that OQ equal to 12 cm. So you take the Q out of the circle. From the Q to O, if you take center of the circle, you take the center of the circle O, from the Q, the distance is they given 12. From the O to B, take the P point on the circle. If you draw the tangent, So they asked to find what is the length of PQ. They asked to find what is the length of BQ. That length they ask. So simple, we know that the tangent and to the radius, here it became a 90 degree always. So 90 degrees is think about the right angle triangle. So if we take as a 90 degree opposite hypotenuse side, then it's then we have remaining two sides, adjacent side and this is a hypotenuse side, adjacent side, like that we can take. So always right angle opposite side is take as a hypotenuse. So sum of square of the hypotenuse side equal to sum of square of the remaining two side using the Pythagoras theorem. So we can write OQ squared equal to OB squared. OQ squared equal to OB squared plus BQ squared. So here 12 squared, here the given radius they given 5. So 5 squared equal to BQ squared. So 12 squared became 144. So 144, 5 squared became a 25. So minus 25 equal to BQ squared. Then you subtract 144, subtract 25, 3 will come 14, 9. So 13, so we have 119 equal to BQ square. They ask only the BQ, then we can write square root of 119, square root of 119. So take the option D is the correct answer. So fourth one, draw the circle and two lines parallel to the given line such that the one of tangent and the other secant to the circle. So fourth one, they ask to draw tangent and secant to the parallel. For example, you can draw any side tangent. If you take as a tangent, then draw the line secant. So both should be parallel. So like that they ask to draw the diagram. So already I explained about, so secant is a tangent.